Welcome back, and we are now moving along with specific latent heat. Latent heat means hidden. Latent heat does not cause a temperature change, it just seems to disappear. A pure substance melts at a definite temperature, called the melting point. It solidifies at the same temperature, which is also known as the freezing point. A pure substance boils at a definite temperature, called its boiling point. Pure substances do this due to latent heat. So in other words, ice melts and freezes at 0 degrees Celsius if it's made of pure water. During solidification, a substance loses heat to its surroundings, but its temperature does not fall. Conversely, when a solid is melting, the heat supply does not cause a temperature to rise. For example, the temperature of a well-stirred ice-water mixture remains at 0 degrees Celsius until all the ice has melted. Heat, which is absorbed by a solid during melting or given out by a liquid during solidification, is called its latent heat of fusion. Latent means hidden and fusing means melting. Latent heat does not cause a temperature change, it seems to disappear. The specific latent heat of fusion of a substance is the quantity of heat needed to change unit mass from solid to liquid and liquid to solid without temperature change. It is measured in joules per kilogram or joules per gram. In general, the quantity of heat EH to change a mass M from liquid to solid or from solid to liquid is given by EH equal to mLF. And sometimes to remember that, I would tell students to say, my life. Oh. Now, latent heat is also needed to change a liquid into a vapor. When steam condenses to form water, latent heat is given out. This is why a scald from steam may be more serious than one from boiling water. The specific latent heat of vaporization of a substance is the quantity of heat needed to change unit mass from liquid to vapor without a change in temperature. In general, the quantity of heat EH to change a mass M from liquid to vapor or from vapor to liquid is given by EH equals to mLV. The kinetic theory sees latent heat supplied to a melting solid or an evaporating liquid as enabling the molecules to overcome sufficiently their forces of attraction and allow greater freedom of movement. It increases their potential energy but not their kinetic energy, which increases if the temperature rises. And so here we have a cooling curve and a melting curve. At the plateau, you see that there is latent heat of fusion existing. In the case of, well, this is in the case of, we'll call this a cooling curve or freezing curve. So this is like something you would see when you're allowing a wax to solidify, because those actually solidify at room temperature. And this one will be maybe boiling water, so that or melting ice. We would see ice melting, yeah. So yeah, something like that, melting ice right here. So where there is a change in phase or state, you would see no temperature change. There would just be a plateau. Same thing here, you have a liquid and solid existing at the same time, so you will have a plateau. And this is where this plateau would indicate the freezing or the melting point of the solid. Evaporation causes a liquid to vaporize and occurs at the surface of a liquid without ever reaching its boiling point. Evaporation occurs most when there is a lot of wind, plenty of sun, and if there is only a little water vapor present in the air. What are some of the differences between evaporation and boiling? 1. Evaporation can happen at different temperatures, and boiling happens at a specific temperature for any given substance. Evaporation happens at the surface of a liquid, whereas boiling happens in the liquid itself, right? Evaporation increases due to surface area, so the larger the surface area, the faster the evaporation occurs, whereas boiling happens at one specific temperature. Let me know if you know of any more differences in the comments below. Now, boiling and evaporation are both processes that need latent heat of vaporization. The molecules of a liquid have an average speed at a particular temperature, but some are definitely moving faster than others. Evaporation occurs when faster molecules escape from the surface of the liquid. The average speed, and therefore the average kinetic energy of the molecules left behind, decreases. That is, the temperature of the liquid falls. Now, we have things in our houses, that our homes, that basically use the way latent heat works to operate the device. The device operates off of the removal of latent heat. For example, refrigeration. In a refrigerator, heat is taken in at one place and given out at another by the refrigerating substance that is being pumped around in a circuit. The coiled pipe round the freezer at the top of the refrigerator contains a volatile liquid. This evaporates and takes latent heat from its surroundings, so causing cooling. So the heat is taken out from the fridge box itself by the coolant that's traveling through the fins. So it's going to enter in the box through fins, and that is removing the latent heat basically, which will then be expelled to the environment via the black fins at the back. That's why when you stand at the back of a refrigerator, you would feel some warmth coming out. That's the warmth coming out of the inside of the fridge. So in air conditioners, cooling by evaporation is also used. Warm air is pulled into a dust filter by a fan and cooled by supplying latent heat to the liquid evaporating in the coiled pipe. So the hot air that's inside of your room right now, if you have your air conditioner on, is being sucked in by a fan, and whatever coolant is running through the pipes that is inside of the air conditioner will remove that heat, which is called latent heat, and is going to be expelled to the surroundings outside in the environment. That is why when you stand by the fans or fins outside of an air conditioner, by some type of window or wall, it feels hot, because the hot air that's coming out of the room. Alright, so here's the end of latent heat. I hope this helped, and do enjoy the rest of my read-alongs to help you study for your exams or whatever tests you have coming up. See you later.